All right. Hi, everyone. Welcome to our webinar. Today, we're going to address preconceptions about AI-based visual inspection. And first of all, I'm very happy that you're here. Thank you so much for joining. My name is Eileen. And with Will, Benny, Mike, and the rest of our technical team, we're going to help you getting a better clue on how to employ this amazing technology. As a little introduction, we are an AI-powered quality control company. And with our platform Spectron, we are able to not only reduce the amount of data headaches, but we're also providing seamless integration up to 99% accuracy and 24 hours to onboard. Now, let me see if this slide is running through. Give me 1 second, please, okay?
Thanks, Aline.
All right.
I got the slides
Yes.
working here very nicely.
All right, perfect. So let's go to the next one then. So today's agenda is, as I said, we're going to address 5 top preconceptions. And this is about really debunking common AI myths in quality control. We're going to give you real world insights and practical applications while showcasing how our Spectron platform simplifies AI adoption and scalability. Then I'm going to open up the floor for our live Q&A. So this is really a great opportunity for you to really ask any questions you have about AI in quality control and how we can help you get started. All right, I'll pass it over to Will, and we'll start with the first preconception.
Thank you very much, Eileen. And in fact, before I go over to the first preconception, I'd like to just briefly provide a little bit more of a background information about this one. First of all, this is indeed our inaugural first webinar. So if there's some small kinks and not quite right items or aspects to it that we still have to iron out, please bear with us. But we really hope that we can provide some value in this. It is one of hopefully going to be several of these type of webinars, and we're going to answer a couple of the questions that we have come across so far, talking to manufacturers, talking to QC implementers, and hopefully some of these will address questions that you might have as well. We have certainly encountered them, and we are quite accustomed to answering them at this point. And that is the aim, right? To share some of these questions with you and some potential answers. And of course, it will have somewhat of a Zetamotion Spectron spin, but a lot of this should also carry just general information value. Right. You will have seen from my lovely colleagues in the chat, I believe Mike put it there already, you can already start providing questions if you have any. For that, you can use the little activities button on the bottom right. It comes in the format of a square, a triangle, and a circle. And then there's a Q&A section. And in the Q&A section, you can provide questions in addition to what we're going to outline. I'm going to be, first, I'm going to go through some of these preconceptions that we have pre-prepared. And then we're going to open up the floor to everyone to answer or to ask you further questions. However, we also have a couple of questions that we prepared, which have been asked beforehand and which we think would be interesting for others as well. So without ado, let's get started on the very first one. Very first one, preconception that we very often come across is you need to hire a lot of people if you actually want to make it work. Now, where does that come from? The trouble that we often see is that there are a lot of tools out there now. There are a lot of hardware components out there, which even seem quite affordable, seem to be quite accessible. Some of these can be downloaded for free, and you can get set up relatively quickly and easily, but it is quite limited. So you get something working, but is the thing that you get actually achieving what you wanted to achieve? That's the bigger question. And one of the biggest problems with some of these approaches that we see out there is that they tend to externalize the challenge. They externalize the difficulty of getting over that magical 80% number, right? And what I mean by that is you can relatively easily get some hardware and one of these inspection platforms and get started on uploading your data, right? You can start your training, you can start your labeling and so on, and you get good first results, but then it becomes more and more difficult. And we have heard the story quite a few times that in the end, manufacturers had already invested in very expensive hardware and various software platforms, but it just has proven to be extremely difficult to get to that final stage, right? To that final level of accuracy where it truly elevates operations on the production line, truly provides the value and the ROI that people were looking for. And in the end, they had to hire additional people, right? So this is one of the biggest problems. And this is, even though it is a preconception, it is in a way also true for many occasions. However, it doesn't have to be true. There are also models out there, and we happen to be one of the cases that are structuring our offering along these lines, where that difficulty is internalized, right? So rather than just handing you a bunch of hardware and software and then leaving you alone to figure it out, our business model is one where we internalize that. So we take ownership of the challenge and we provide a success guarantee. That means when you look at this diagram here, all you have to worry about is having the inspection station in place, managing your inventory, as in you onboard new products, you give us the single onboarding scans that are required per product, and you keep an eye on your reports. But everything else, which is often externalized, the training, the data preparation, curation, and so on, all of this we handle on our side, right? So you could think of it as like a tiny bespoke or a tiny custom solution provider, but in a format that is much easier and comes with a much friendlier price tag. So first preconception, you need a machine vision expert, you need to hire a bunch of PhDs. Not true in all cases and not true in our case, because we have the team that essentially becomes your externalized service provider with a whole bunch of PhDs, with a whole bunch of experts dedicated to solving your problems. Right. Second, you need lots and lots of data. This is another very big one. And this is another showstopper that we see in a lot of industries. Because what a lot of these tools require is an enormous amount of data. You may have come across the term junk in, junk out before, which is a bit of a paradigm, a prevailing paradigm in this machine vision, computer vision landscape. And it describes the concept that if you do not feed sufficiently high quality data and sufficiently curated and labeled and prepared data, the results that you get out of it are going to be poor as well. Right? And this is true. This is true for most approaches. If you do not have enough data, and if that data is not prepared properly, you can expect to have pretty bad outcomes. Right. So this is what a lot of the tools that you can currently make use of look like. It will have something similar to this, some diagram that outlines a similar pipeline. You need lots and lots of data, lots of curation. Do your first training, second training, retraining, revision of the training, and so on and so on. And slowly you can creep up the accuracy rate, right? But that can be quite tedious, and it can be quite difficult in many cases to have that data available. It also kind of connects to the first point where we were talking about having to have a dedicated team, because in many cases it appears as if you need a lot of people to collect this data and to curate this data as well, right? So how can we do things differently, or how can an approach do this differently in general? It is possible if you can utilize synthetic data. And synthetic data allows you to work off of a minimum amount of these critical resources of data, time, and manpower, right? So where usually someone would have to sit down and collect thousands of pictures and then sit down again and curate all of these pictures, with a synthetic data approach like ours, you can simply run a single product through the inspection station, collect one good scan, teach us the same way you would be teaching a human worker, right? Where you're not spending time showing the human 1,000 onboarding pictures. Instead, you share with the human 1 or 2 examples, and then you spend some time explaining the semantics of the defect, of the quality parameters, right? And from there, the human is able to extrapolate, is able to understand what you mean when you're talking about these defects, and is able to apply that to additional products, right? And this is what we can offer with our approach as well, right? So there's no need for this huge data samples that have that are often very costly to prepare and to curate, right? And this is particularly applicable in several industries, and we have only singled out 3 here where we believe that this, or where we have found that this is particularly problematic. The first being industries where there's very limited data available. So we see this especially in high tech. We've seen it in aerospace, which is one of our areas of application, where one of our clients has very, very low production runs. They are producing extremely expensive systems, like very expensive products, and they have production runs of less than 20 a year, right? With this, you cannot generate a data set. You cannot gather the kind of data set that would be required for a conventional system, right? A second example would be what we call non-uniform and noisy products. So whenever you have a product that by virtue of its nature, or by the virtue of the production processes, features these non-uniform aspects to it, it can be very difficult to achieve high levels of accuracy, because traditional systems like to spit out endless false positives, right? So one of our projects that we've run previously that is just an absolute poster child for this is roof shingles. Now, roof shingles are they come in different forms, but the ones that we were working on is a composite product that is made from glass fiber backing with bitumen and asphalt on top, as well as sand granules, right? And that, as you can see here, right, it's a bit small, but you can probably still see, is a nightmare to inspect with machine vision, because there's so many properties, so many parameters here, which are very easy to explain to a human, but very difficult to parse into the understanding of a machine vision system, to explain, the quality of this paint line, right? How good this has to be, because to a human you can just say, look, it has to be visible enough for a human not to miss it, but it doesn't have to be fully continuous. It can be a bit splotchy, but within certain parameters and so on. And this is quite difficult to explain to a system, right? But if you have the ability to generate arbitrarily large data sets, even that level of understanding, even that level of semantics can be incorporated and can be accounted for, and we can achieve high levels of accuracy regardless. Right? And the third area where this approach shines in particular is whenever you have agile manufacturing, whenever you have a high amount of variations, when lots and lots of different types of designs are being applied. Traditionally, you would have to run this cycle of training for every single design, for every single variation. You have to, again, collect a large data set, do the curation, do the labeling, and it can become prohibitively expensive economically, right? But again, if you have a system that is able to onboard quickly and is able to work off of a single onboarding file, that can be a problem that can be solved. And you suddenly, where previously this was one of your biggest troubles, you need lots and lots of data, that can be a solved issue, right? All right, preconception number 3. And this is also one that we've heard many times. Inspection only works on non-reflective products. This used to be more of an issue when we had less robust models, when we had less robust technologies, both in terms of software and in terms of hardware. And we had, quite some trouble in these areas before, and that's why this preconception is still lingering in the industry. But by now, this doesn't have to be the case anymore. And in fact, we have use cases where we are working with transparent materials, semi-transparent materials, and also extremely challenging materials like the aforementioned roof shingles, because they have fresh bitumen applied, which is at the same time reflective, but also extremely light absorbent, because it's pitch black, but it's glossy because of the freshness, right? It's still fresh and almost liquid bitumen that is reflecting light on the one hand, but on the other hand, absorbing a lot of light very easily. So in a combination of the latest hardware, using things like dark field, polarization, and other types of sensors that we can interface with, as well as the latest in machine vision research, we can address even extremely challenging materials. Just this week, we had an interesting request from a company that is making specialty solar solutions, where we have to, or where one of the challenges is to find defects within the solar cells that are embedded in the transparencies. And that indeed is also doable, right? Again, in a good combination between hardware and software, even such challenges can be addressed. So do not be dissuaded by thinking probably my material is too weird, is too strange, is too challenging, and especially if humans can't do it, surely the machine can't do it either. Let's have a look at it. Probably there's a solution for it, right? Right. This one, I think I already addressed to some degree, right? In the end, it's my responsibility. And this is indeed what we see in many cases, where essentially the manufacturer is told, well, it's your fault. If you didn't achieve what you set out to achieve, it's on you. It's because you didn't upload enough data. It's because you didn't sit down and do enough labeling. It's because you didn't spend enough time training and retraining. And we see that this is really a huge headache, right? Because again, it features into this problem that in the end you have to hire a bunch of people who make it work. Or worst case scenario, if even your freshly hired machine vision PhD can't make it work, you have to find some consultancy or some extremely expensive solution provider to sort this out, right? And that can be, really problematic. So this is one of the things that we have made have made a core tenet of our offering, which is that we own that challenge, right? We make sure that we do not leave your facility until we have achieved your level of accuracy, the parameters that you need to meet. Because if you have a system that, let's say, only inspects half of the things at the accuracy that you need, and the other half is not up to spec, then in the end you still have to run manual inspection, right? And then you win very little, right? So this is quite problematic, right? But it can be solved. It can be done. We have a dedicated team that it becomes, you can imagine as if you hired a whole team that is passionate about making it work for you. And that's what it should feel like if you're engaging with our system and our team as well. Right. Preconception number 5. AI inspection is hard to install. Once again, this is one of the troubles that you have when you try to make it work yourself. There's a lot of hardware out there. There's a lot of software out there. If you are one of those magical unicorns where everything is already beautifully standardized and your systems, your PLM system, your IoT system is already speaking perfectly all industry standards, and you have zero custom reporting, you have zero custom requirements, then maybe you get lucky and you can sort things out relatively straightforwardly. But as we have experienced, that's rarely the case. Usually there's quite some integration work required, and that can be quite difficult. But what we have done is that we have catered, or we have tailored our platform to be maximally connective and compatible, as in it speaks all of the industry standard protocols. It can plug into all of your systems. We, by default, make all of our data, or all of the data that we have generated about your product, about your production line, available. That to us is a matter of principle, because we think this is something that is about your product, so you should own it and you can do whatever you want with it. And we make sure, again, that it interfaces in a way that you need. Because, again, if you have a system that does only a part of the job, but then stops at connecting the results with your production line and with the further steps, right, then you have to spend so much more time sitting someone down who does that integration work or does that connecting work, and it's questionable how much ROI you have in the end, right? But it doesn't have to be this way. You can also work with someone who has that in mind already and is working on it. Right. All right. This is the first 5 of more to come in the future. But I see there has been quite some questions coming in already, and I think we've scheduled this to be 45 minutes, right? So I want to make sure we have enough time to actually address these questions as well. So let's have a look at some of these questions, Aline.
Yes, let me have a look. But before we start, I would love to revisit the practice of actually asking questions, just to make sure that everybody understands. So to submit a question, you click on the activities icon, and then you scroll down to the Q&A section. And if you want to, we can see if it comes through by typing hello, but we've already received some questions there, so I understand that that's understood. So let's start with the first one from, let me see, are there any systems in the UK that I could visit and see it in action?
Now, this is a tough one in the sense that our systems tend to be implemented in sometimes relatively critical operations. So it's a case by case matter whether our customers are happy to receive anyone. We do have a very friendly partner in the Netherlands who's generally quite happy to receive anyone to have a look at a deployed system. In the UK, I'll have to get back to you, Barry.
All right.
But we're happy to run virtual systems that we can show you. Right? There's plenty of material that we can show you, including even a kind of virtual POC where we can use your data to showcase what it would like if it were to run in reality.
All right. Thanks so much, Will. Next question is from Rice. Can you give an example of the type of hardware that Spectron integrates with?
That is a very good question as well. And once again, this is to us a matter of principle as well, because it connects to the whole offering that the Spectron platform represents. Because what we do not want is to provide a very limited set of sensors or well, some of the providers out there have 3 cameras or 3 types of cameras, and either you fit into exactly the parameters that these cameras or sensors can address, and then you're good, and you probably still have to spend a lot of time making it work, or you don't fit exactly into that configuration, and then you're screwed, because then you have to go and find some bespoke solution provider who can create something for you that works. Right? So what we have built this platform to do is to be as hardware agnostic as possible, right? Which means if you're working with us, if you have an inspection challenge, we don't want to be hands off. We don't want to just send you something and leave you alone with it, but rather we want to arrive with empathy, with understanding, and with respect to what you are actually doing. We want to spend some time with you, understand your product, understand your current processes, understand your challenges and your goals where you want to end up with, right? And in that conversation, we work out what is the right kind of hardware, right? And this is a very important conversation to have for many reasons, not least of which is that in many cases, it really is a co-discovery journey between us and the manufacturer to even truly figure out what parameters can be assessed in which way and how are they best defined, right? Because in some cases, the human understanding is relatively easy, but parsing it again into a computer vision system can be quite challenging, right? So instead of just throwing something at you, we want to spend time with you to find out what is the right kind of sensor, what is the right kind of vision system or laser line scanner or dark field, bright field, whatever it might be, right? And then we look at the results together, and then we confirm that this is indeed capturing your parameters optimally. And then we know what is the right hardware, and that is what we aim for, right? So in order to be able to provide this service or to provide this approach of making sure that we deploy whatever is best for your case, we build the platform to be maximally compatible, right? So that's the long answer. The short answer is lots and lots of different hardware types, all of the industry standards. In most cases, actually, we can get away with vision cameras because with latest AI developments, you can do quite a lot. What previously may have required even something like an expensive laser line scanner, you can now use clever optics and ML to solve. But we can interface with just about anything that has a standard industrial protocol connection. Right. I hope that long-winded answer addresses your questions mostly.
All right, let's go to the next one. Can you provide a typical cost for implementing a system?
Yeah, this is a very good question. And you will get the answer that you probably expected you will get, which is always the same, which is it depends. Of course, it depends. So rather than giving you a very specific answer, I think I can give you some perspectives on how we arrive at our pricing and how our business model works. And then that some extremely large ranges of how that might end up. So our goal is really to be a long-term partner, which means we aim to make our revenue not based on a one-off deployment, but rather on the basis of that partnership and to continue to solve or to make sure that the system works for you. So what we would generally do is for the initial deployment, the figuring out what is the right kind of inspection hardware, to set up the hardware, to implement the hardware, all of these costs we like to pass on at cost, essentially, right? So no markup on the hardware. We're also very happy to share with you the BOM exactly of what the system is and what it looks like and what it costs, and pass that on to you. And from there, invoice the usage of our platform, of the continued ability to onboard new products, our availability for change requests, for feature requests, and so on, and make that available on a pricing model that is dependent on how many product variants you are onboarding, how many parameters the system is assessing, and so on. So typically, we can offer on the deployment a very competitive pricing, in many cases cheaper than, let's say, some of these expensive camera systems that come with some software. I'm sure everyone knows the big players like Cognex and so on. So for and really, this is just some super ballpark figure estimates here, but for a given industrial inspection system, you'd be looking at a hardware implementation price of between maybe 5,000 at the cheapest, 20,000 at the more expensive end on the hardware. Implementation, depending on how straightforward it is, maybe again as cheap as 5K, going up depending on the complexity, and then on the longer term licensing, you'd also be looking at a very large range depending on the parameters, on the complexity, on how many inspection stations you might have, how many variations are there. So it's a very long range from something like 20,000 to 100,000 a year, something roughly like this. Or it could even be, even friendlier depending on how tough or easy it is. So as you can see, it's a big range. We don't need to be very rigid in this. For us, it's really about creating value, and our technology allows us to do things faster and more cost efficient than some other approaches, and that allows us to be quite competitive on the proposals that we give to given challenges.
Yes. And with that, we're gonna ask another question from Rice, which is Spectron specifically targeted to inline inspection, or can you see it working on with quality lab microscope?
Yeah, another good question. We are happy to work with inline inspection, and here we see some of the real data magic appearing whenever there's several inline inspection system, especially, and we can start doing some data correlation analysis, which then can be translated into cause and effect analytics as well. But the system is perfectly happy to work as an offline inspection station, or on an offline inspection station as well. So it really doesn't matter. We tend to have models that are extremely fast as well. So the fastest implementation we've done is on a 4 meters a second production line, where we are inspecting at near real time, something like 200 milliseconds delay, assessing more than 30 parameters. So it's quite quick and assessing a lot. And the system is happy to do that. Or you can have it as a standalone station where you put samples from a lab and have that analyzed as well. It really doesn't matter.
All right. Next question is, can a single system be used for multiple variations of parts?
Another good question. Lots of good questions coming in, indeed. Yes. The answer is yes, it can, if you wanted to do that. So again, this comes down to talking to a customer and assessing what their requirements are, right? So if you have lots of different variants that come through a certain system, then we put together a design for an inspection system that can cater to whatever you have on your horizon, what the system might look like, right? So that means we might have to scale it in a way that includes, that incorporates the ability to run through much bigger products than you're currently running, right? Let's say you are currently doing panels that are 1 by 2 meters or so, but in a year time, you know that you're going to produce 2 by 3 meters, huge panels, right? Then we can already build the hardware or design the hardware in such a way that you can already start testing the big ones, or that it can easily be upgraded, right? So we can add additional sensors, we can add additional hardware, either directly in the first deployment, or again, build it in such a way that it can be added later on. So this to us is really part of this making sure that what you get solves your proposition, right? And in most cases, or one of these use case or cases where I mentioned earlier, where our approach shines in particular, is having lots of variations, right? So most of the variations we see do not differ massively in their appearance. They as in, it's not like going from a bicycle to a car difference. Usually we see variations of cars or variations of bicycles, right? It's not a radically different type of product. So it's already out of the box built to cater to different variations. But if you indeed want to inspect both bicycles and cars at the same time, then even that can be doable, right? It might be a bit more complex in the engineering, and we might have to figure out whether it isn't more economical to have two inspection stations instead. But that is something that we would figure out in a conversation.
All right, those were all the questions. Thank you so much. Now, we do have a couple of minutes left, and I suggest we go through a couple of them if we have time, right?
Sure. I think we have, we have 3 minutes left.
Yes.
So that might be just enough to have a look at one or two of the questions that we received ahead of time. And the first one was here. What are the initial steps to implement a computer vision or computer vision and AI in someone's QC? And for us, what I recommend, and obviously this is very much along the lines of how we do things, is that it all starts with really sitting down and identifying what you truly want. What are your goals? What do you want to achieve? And again, some of this is not as simple as it might look at first glance, because you do need to think, what can you how can you translate what you're currently doing into a digitalized format? But you also need to get out of your out of the human perspective, because sometimes we see there is a limitation of imagination, essentially, because you and obviously it makes sense, right? One tends to be limited to only imagine what is possible for a human, right? We see what a human can do, and then we kind of extrapolate that that's probably what the machine can do, but slightly better, just not fatigued and kind of not getting tired and so on, not missing things. But it's still very much imagining like a humanoid robot. But there's a lot more opportunities out there. So we might be able to assess something that isn't even part of your current QC process, right? Because you can't, because a human can't do it, or you don't have the right type of a sensor to do it. But it might be very beneficial for you, right? So truly sitting down and identifying this and setting the goals, quite important. Having a partner that can help you find the right kind of hardware and software, and then start with a first project. Start with something to boost your confidence. Something that we come across quite a bit nowadays is a lot of burned ground. Is a lot of people who have tried something, maybe sunk quite some money into a certain into a POC or a pilot, and then it turned out to be very underwhelming and underperforming. So we suggest build some confidence, have some smaller scale setup, see if it performs as you want it to, and then from there move to the next steps. And that's also how we like to operate, right? We like to run feasibility studies, show you what we can do, smaller projects. I mean, obviously, we're happy to get started right on a big deployment, but we're not shying away from building that confidence in the first place. Right, we are at the end of our allocated time. I would like to give one more opportunity for another question from the floor. Otherwise, I think we'll save the other questions for our next installment with 5 more preconceptions and 5 or several more of these questions.
Yes. Thank you so much, everyone. We really enjoy this, and we hope you found this a great learning experience for you. Thank you.